we have already started exercise 9.5, that is your homogeneous form, right? The method checking method I have written on the right hand side. I am continuing with the exercise we have already done in the previous session, total question 1 to 6. Now I will be proceeding from question number 7, right? Same method, same exercise, no difficulty level, same difficulty level is there as we have done in question 1 to 6 also, right? Question number 7 is x cos of y upon x plus y sine of y upon x whole multiplied by y into dy dx is equal to y into sine y upon x minus x cos of y upon x multiplied by x dy, right? X cos y upon x plus y sin y upon x into y dx is equal to y sin y upon x minus x cos y upon x into x dy. Okay, now first of all we have to check whether this equation is a homogeneous form or not. For that, first of all write this equation in standard form, right? That is dy by dx will be dy is here, so take dx in the denominator part and this whole factor here. You will get x cos y upon x plus y sine of y upon x whole multiplied by y divided by this factor, that is x into this factor y sine of y upon x minus x cos of y upon x, right? Let this be function of x comma y. Again checking, f of lambda x lambda y, right, is equal to, substitute lambda y in place of y and lambda x in place of x, cos of lambda y upon lambda x plus lambda y into sine of lambda y upon lambda x whole divided by this lambda x, then lambda y into sine of, it will be lambda y upon lambda x minus lambda x cos of lambda y upon lambda x, right? Lambda will be cancelled. After here lambda cancelled, this is also cancelled, this lambda is cancelled with this, take lambda common, so this lambda will also be cancelled after taking common, so you will get lambda raised to a 0 into function of x comma y, which is this. Let this equation be 1. Therefore homogeneous of degree 0, right? Again put y is equal to vx. Now I will rub this part. This is your checking part. Now put y is equal to vx. Let us start. Differentiate it. Dy by dx will be v plus x dv by dx. Put in 1. So you will get dv by dx v plus x dv by dx is equal to, here put y is equal to vx, so you will get vx x cos vx upon x plus vx sin vx upon x whole divided by x vx sine of Vx upon x minus x cos of Vx upon x, right? So I have substituted y is equal to Vx and dy by dx is equal to V plus x dv by dx in first equation. Now x is cancelled, this x is also cancelled, this x is cancelled, this x is cancelled, this x is cancelled, right? Now take x common from here, you will get Vx cos V plus V sin V upon, take x common, then V sin V minus cos of V. Again x is cancelled, right? Now take V to the right hand side. So you will get x dV upon dx is equal to V cos V plus V sin of V upon V sin V minus cos V minus of V. Now take LCM, V sin V minus cos V, you will get V cos V plus V square sin V, then minus V into V, V square sin V, then minus minus plus V cos V. V square sin V will be cancelled. V to cancel with this, so you will be left with x dV by dx is 2V cos V upon V sin of V minus cos of V, right? Now separate the variables, you will get dx upon x is equal to V sin V minus cos V upon V cos V, half can be taken out, dV, right? Now integrate both the sides, you will get log of x is equal to half. Now derivative of V cos V is V minus sin V, you can take minus sign out also, minus sign will be adjusted, take minus here plus here, so derivative of V cos V is minus V sin V plus cos V, so you can write as log of denominator plus a constant c, right? So again this can be done as log of x plus half log of V cos V is equal to c. These two terms can be written now as log of x into will be taken at the power, then it will become log mn, that is V into cos V under root is equal to c. So this can further be written as x under root V cos V is equal to e raised to power c with plus minus sign, which can be taken as, let it be c dash c, now it will be c. So on squaring, or you can on squaring, you will write x square V cos V is equal to e raised to power minus twice c dash, which can further be written as c, right? Now substitute the value of V, that is y by x, so you will get x square y upon x cos y upon x is equal to c. X will be cancelled with x, so answer is xy cos y upon x is equal to c. This is your question number 7th, right? Note it down. I think this is visible to you. Okay, I will write it again. X square y upon x cos y upon x is equal to c. X will be cancelled, so you will be left with xy into cos of y upon x is equal to c. Final answer, right? Now question number 8. Note it down first. The homogeneous equations are a bit lengthy. But the next topic, that is in that topic also questions are not so much lengthy, and the previous exercise also the questions were not so lengthy. Only in the homogeneous form the questions are lengthy. That's why sometimes if the question of homogeneous form comes, it comes under the 6 marks question if it is a lengthier question, right? Noted down. Question number 8. Question 8 is x dy by dx minus y plus x into sine of y upon x is equal to 0, right? Again, first in standard form, x dy by dx is equal to y minus x sine of y upon x. Then dy by dx will be y upon x minus sine of y upon x, which is in the form f of y upon x. Therefore, it is homogeneous equation of degree 0, right? So this is also the method I have told you that you can use this method also for explaining the equation to be the homogeneous form. So you can use it also. Y is equal to Vx as usual. Dy by dx is equal to v plus x dv by dx. Put in 1. This is your equation 1. You will get v plus equal to Vx upon x minus sine of Vx upon x, right? X will be cancelled, x will be cancelled, v will also be cancelled. X dv by dx is equal to v minus sine of v. V will be cancelled. Now separate the variable. You will get dx upon x is equal to minus 1 upon sine of v dv. Then integrate the terms. Log of mod x is equal to, this is your minus integral cosecant v, which is minus of log of cosecant v minus cot v plus a constant c. Now substitute the value. Cot of log of mod x plus log of cosecant, put v is equal to y by x, so you can write it y upon x minus cot of y upon x is equal to c, right? Question number 8, this is your, so you can again add these two. Log m plus log n will become log of mn, that is x into cosecant y upon x minus cot of y upon x equal to c. Then eliminate x, eliminate log, get x into cosecant y upon x minus cot is equal to plus minus e raised to power c. So this can further be written as cosecant y upon x minus cot y upon x is equal to k plus minus e raised to power c, new constant, right? So this is your answer. And in your book also, the answer, this can further be simplified, can be changed to sine and cos also. This can further be changed in sine and cos also. In your cos NCERT book, answer is 1 minus cos y upon x is equal to c sine of y upon x. Again the same thing. This can further be changed to this solution also after eliminating cosecant, write cosecant as 1 upon sine, write cot as cos upon sine, you will get this answer. So there is no need to change this question, this answer to this form. It is your wish, right? You can leave the answer here also, right? Now question number 9th. You should have confidence in yourself that your answer, your method is correct, everything is correct, then the answer which is coming, that is also correct, but only the difference will be how to transform it to the answer which is in your book also. So that is only the way that you can change the trigonometric values, you can use the trigonometric identities for the same, you can use the properties of log for the same, right? Now question number 9. Question number 9 is y dx plus x log of y upon x dy is minus 2x dy is equal to 0. Y dx plus x log of y upon x dy is minus 2x dy is equal to 0. This is the question number 9. Again, you can see that the degree of y is 1, it is also 1, degree 1, degree 1, degree 1. It is clear that it is homogeneous. First write in standard form. Take dy common from these two terms. You get x log of y upon x minus 2x is equal to 0. Now y dx, take these terms to the right hand side. Minus n will be adjusted here. Write this term as 2x minus x log y upon x into dy. Minus 2x will become plus 2x. This will become minus of x log y upon x on going to the right hand side. Now take dy by dx will be y upon 2x minus x log y upon x, right, which can be taken as f of x comma y. Now again checking part, put lambda x in place of x, lambda y in place of y, you will get lambda y upon 2 lambda x minus lambda x log of lambda y upon lambda x, right? This lambda will be cancelled with this. Now the lambda from the numerator, take lambda common, you will get 2x minus x log of y upon x. Again lambda will be cancelled, so you will be left with lambda raised to power 0 into the same function, that is f of xy. The equation is homogeneous with the degree right. Now suit the method. Now let y is equal to vx, again differentiating, dy by dx will be v plus x dv by dx, again substitute in 1, right? Now 1 is your equation this, so you will get v plus x dv upon dx is equal to, put y is equal to vx upon 2x minus x log vx upon x. X is cancelled with x. Now this x will be cancelled with the denominator part x, that is here. Now take v to the right hand side as usual, x dv by dx is equal to v upon 2 minus log v minus of v, take LCM, v minus 2v plus v log of v, which is equal to v log of v minus v upon 2 minus log of v, right? Now variables can be easily separated, so you will get dx upon x is equal to 2 minus log of v upon v log of v minus v into dv. Now integrate the terms. Now derivative of v log v is derivative of v log of v minus v with respect to v will be v into 1 upon v plus log of v minus 1, that is log of v, right? The derivative of this part is log v, which is written in the numerator also. This can be taken now as 2 can be taken out, dv upon v log v minus 1 minus integral log v upon v log of v minus v dv, right? This can be taken as twice I1 minus I2. Let this be equation number 2. Now I will treat I1 as separate question, I2 as separate question, then substitute these two values in 2, right? Note it down so that I can proceed further. Now I1, your question I1 is 1 upon v log of v minus 1. Now derivative of log v minus 1 is to put log v minus 1 is equal to t. You will get 1 upon v dv is equal to dt. That is I1 will be dt upon t, which will be log of t, that is log of v minus 1. I1 will be this, and for I2, see the derivative of denominator is in the numerator, so that is log of denominator part, that is log of v log v minus v. So this I1 and I2, these values can be substituted in 2. So you will get integration of 1 upon x is log of mod x is equal to 2 times I1, that is 2 log of log v minus 1, then minus of I2, that is log of v log of v minus v plus a constant c, right? Now substitute the value of v. This can be written as log of mod x is equal to, this will become log of v minus 1 whole square minus log of v minus v plus c. So this further can be written as log of m minus log n, that is log of v minus 1 whole square upon v log v minus v plus c. This is your log x, right? Now this can be taken there, so you will get log of x minus log of this, so you will get log m minus log n, that is log of m upon n. So this will become v log of v minus v upon log of v minus 1 whole square, which will be equal to c, and this further can be written as x. Now you can put the value of v also, that is y upon x log y upon x minus y upon x upon log y upon x minus 1 whole square as e raised to power plus minus e raised to power c. This is your value with mod, right? Now your answer is x can be cancelled, so you will be left with y log of y upon x minus y is equal to, this can be taken as k k times log of y upon x minus 1 whole square. This can be your answer. In your book, answer is your cy is equal to log of y upon x minus 1. Log y can be taken out, so you will be left with log y upon x minus 1 is equal to k times log of y upon x minus 1 whole square. This will be cancelled, so you will be left with y is equal to k times log of y upon x minus 1, right? So this is your answer. These two answers are same. In your CBSE, in your NCERT book, answer is given to be this. So again, you have to adjust the answer for the same. I'm just rubbing this part. You can note it down, the final part. Just check it out, that how the answer is being manipulated. This was the question, this was the proceeding, then final answer was this. Further, this answer was manipulated like this. Again, by using the properties of log. Okay, then you will get this. After that, this. Then eliminate log, you will get e raised to power plus minus c as usual, as you have done in previous questions also. This is your k. Now you can, I am writing this in very simple form. Y log of, that will be clear to you, minus y is equal to k times log y upon x minus 1 whole square. You can note it down here. So y will be taken out, log y upon x minus 1 is equal to k times log of y upon x minus 1 whole square. This factor will be cancelled with 2. You will be left with log of y upon x minus 1. Right? So k can be taken on the left hand side. It will become 1 by k. 1 by k is a new constant. You can eliminate it by c dash also. So you will get this answer, which is in your book. Cy is equal to log of y upon x minus of 1. This is log y upon x minus of 1 is separately written. Right? So this is your answer. Okay? Note it down. Now question number 10th. Question number 10th is 1 plus e raised to x upon y within bracket into dx plus e raised to x upon y bracket open 1 minus x upon y into dy is equal to 0. Right? Now it can be seen that there is x upon y written in the question. So this will be of this type. Dx by dy is equal to a function of x upon y. So first of all, write this equation in this standard form. Take this to the right hand side. So you will get minus sign. This minus x upon y will become plus x upon y. Plus 1 will become minus 1. E raised to x upon y into dy. Now you will get e raised to x upon y minus 1 upon 1 plus e raised to x upon y. And you can see that the whole part is a function of x upon y. Therefore, using this concept, it is homogeneous equation. Right? Now, substitute x is equal to vy. Now note this thing, that in this question you will be substituting x is equal to vy. Right? Now differentiate it with respect to y. You will get dx is equal to v plus y into dv upon dy. Now you put these two in 1. 1 is your this equation. So you will get v plus y into dv by dy is equal to e raised to power, put x is equal to vy or x upon y is equal to v, so you will get e raised to power v minus 1 upon 1 plus e raised to power v. Right? Now take v to the right hand side. Then take the LCM. Then e raised to power v, this will be cancelled. You will be left with e raised to power v minus v upon e raised to power v plus 1. Right? Now separate the variables. You will get dy upon y is equal to e raised to power v plus 1 upon e raised to power v minus v. Minus sign is here also. You can take minus out dv and then integrate. Now derivative of e raised to, this will be e raised to v plus 1. Derivative of e raised to power v plus 1 is e raised to v plus 1. So this is log of y is equal to minus log of e raised to power v plus v plus a constant c. Constant c can be written as log of c also, right? So you will get log of, this will be taken in the left hand side. So you will get log of y into e raised to power v plus v is equal to log of c. C can be taken in mod, right? So further the answer will be y into e raised to power v plus v is equal to c. Now substitute the value of v. E raised to power x upon y plus x upon y is equal to c. So this can further be written as plus x is equal to c. This is your answer. Right? Note it down. This was your question number 10th. Now from question number 11 to question number 15th, the problems are of initial value problem. Right? I will be taking these questions in the next session. Note it down. I will be continuing this exercise in the next session now.